we just had djangocon in Chicago. Oh, that's right. I got to stand in front of the camera. And Django's kind of neat, and except people complain about performance. It's like I actually had somebody ask me, "Oh, is anybody still using Django?" And I laughed out loud and showed him edX. So I want to tell you a story, because I want to get you motivated into taking a look at edX, which isn't just your regular Django app. It's kind of a gnarly big mess. And but I also want you to do it with some perspective. And so my story starts with the first computer-based instruction, or at least interest in that, and how we kind of quickly bridged over from there to edX, and then what that's all about. So let's see, did I do it? Yes. So I'm going to talk about some early history, and I'm going to look at what's going on now. And I'm going to try and get through this in a half hour, which will be a miracle, but so, the starting context is 1960. Style was things, the Soviets launched a Sputnik in 1957, and rocket power was everything. Design and engineering, the Chrysler 300. This was the first car with unibody construction. Woohoo! And people thought that swivel seats for passengers were a good idea. That one didn't last. But there were automatic dimming rear view mirrors, and that one did last. And the Chrysler liked to have these dual quads with, anyway, we don't need to talk about that. Televisions were new, but look at the problems. Philco beats the heat, which is a major cause of breakdown. So even though we had lots of new technology, it wasn't really reliable. So in the context of computing, Fortran 1 is 3 years old at this time. Fortran 4 is still a year away. We're using core memory. If anybody's ever played with any old ancient HP calculator with core memory, you'll appreciate how god-awful slow it is and reliable. You can pull the plug, plug it in a day later, and it'll just continue. It's almost like its own kind of virtual machine. There was no ASCII standard yet. Everything was 4-bit BCD coded because memory was expensive and power consuming. There was no internet protocol, nothing on the lines of interactive terminals, and no multi-user systems. That stuff didn't exist. So here comes Plato from University of Illinois. In 1958, the Air Force had a conference. In 59, a bunch of people at UI had a discussion about, gee, can we really build something to teach people using these newfangled computers? And in 1960, EE at U of I, PhD EE says, I think I can do it. So new technology is kind of rough. You may think you know what you want, but you don't know how to get to it. So the goals were connect people, create an online community. This should sound familiar. And all the interactive stuff. Natural input, including touch. And you got to remember, like in the late 60s, these terminals are running on 1200 baud analog lines, basically phone lines. So updating a screen was expensive, so you had to be clever about it. It also wouldn't be interesting if there wasn't material, so it had to be easy to create material for it. So here's how it goes. 1960, Don Bitzer takes a TV and a custom wired up keyboard, hooks it up to an Iliac 1 and shows, here, I can actually make a terminal interactive. People are really excited. 1961, he actually gets 2 users working simultaneously on this little machine. Look, we can actually have multiple users. This is before Multics, before Unix, before anything. That proved the concept, and by 64 they launched it. They had no language for it, but they had a plasma panel, which was nichrome wires that intersected, and a touch screen that was the same thing. It was plastic holding off little nichrome wires that if you pressed on the plastic, they actually made physical contact. It was neat stuff. And by 1967, it got funded. So here's what that terminal looked like. 512 by 512, 32 lines at 64 characters a line. This was the first multi-user system. The language for programming kind of looked like this in the orange. At 503, forget MVC and separation of presentation from logic. And 5 meant line 5, character position 3. And 715 meant put a prompt up at line 7, character position 15. But there's something important they had, and that was a sentence validator. So whoever wrote a course could write required, ignorable, prohibitive, and even wrong pattern specifications, which no CBI has even now. That kind of got dropped off. So I'll talk about that later. So what happened to Plato? Basically from the early 60s to about the late 80s. I think they shut down the last one in 2004. I actually worked in a Plato lab, ran a Plato lab in the 70s at college. But people tried commercializing it, which means their courseware development costs at Control Data Corporation were like $300,000. This is like in 70s money per an hour of delivery, which was ridiculous. So CDC no longer exists. They invested into this. U of I also tried commercializing it. They no longer exist. You should not just be happy that you're in open source. You should understand why open source exists and prevails. So in 81, the first PCs came out with 5¼ inch floppies, and by 82, Windows 1 was out. And Paul Tenzar, who wrote the tutor language, wanted to put this on a PC, so I was actually part of evaluating the beta of that at University of Arizona, and it was terrible. Just for context, the first release of Python was 91, so that was about 10 years later. So one of the guys that worked on this pretty large team that was funded at University of Illinois was a physics professor, Bruce Sherwood, and he left to Carnegie Mellon and decided he was going to, since Plato was crashing everywhere, but he still wanted to use it, he wrote a version of something like the tutor language in C. That's what CT is.
Hey Yarko, throw a receiver in your front pocket, would you? Thanks. Might help.
You're getting weak reception?
Yeah.
Okay. Is that better?
Yes.
It took 12 years to get it stable enough for him to use it in undergraduate coursework. The second year it was used in 98, an undergrad student, Dave Scherer, said, hey, we could do this, only make it a lot easier to use if we use some graphics library with this new language, Python. So that was Python 1.5. Meanwhile, this is still kicking, and all the rest of tutor and that computer-based instruction, big hope that really drove a lot of computing. And there's actually, Xerox PARC actually came to University of Illinois to look at what they did and took a lot of those concepts. So you could make a loose case that a lot of what we see now, it was influenced by this stuff. So I'm coming kind of to the end of this. So what are the lessons from this really long experiment that University of Illinois and all these funding agencies did? Don't try to commercialize teachers. Make courseware open to whoever wants to teach. And make it easy to teach. Sort of like Facebook makes it easy to make posts. You got to kind of do that with this too. Same thing, it has to be not complicated. And don't try to commercialize teaching, which is what edX is doing. MOOCs are offering free tutorials. More students, more feedback, just like open source, that's what works. So that's the sort of short version of the lessons. And don't close the platform. All of these things, you can actually still see a version of the last version of the running Plato system on a CDC emulator, which is incredibly small. I looked at the repository for the emulator, and the listing fit on my screen. There were no directories. There were like 10 C files. It was kind of funny. And there's a site that has this thing running if you want to see something archaic, but that code isn't open source, so you can't get the code. You can get the emulator underneath, but you can't. So closing the platform kills things. And because there was only a physics professor involved, his only interest was, well, not broad enough interest. So Okay, so this is the big fast forward to now. I stole this picture and I didn't get permission. He didn't email me back, but I kind of like the snake inside the pony. So now there's edX. MIT and Harvard consortium. Stanford joined them this spring. The big news this week is Google joined the edX consortium. This Tuesday they announced it. So this is kind of a big deal. It's a Django platform. The big promise that edX has over a lot of the other open source things now is they're promising natural language grading of paragraph, of essay level submissions, homework, assignments. Right now, engineering and math proliferate on open source education because it's really easy to test a piece of code that you turn in. You run the software, the tests, the functional tests against them, and if it passes the functional tests, you can even run stylistic things, and bingo, you have a grade, even if you have 100,000 students signed up. You can't do that with an essay class. So one of the things that edX is promising and it's controversial is this. That's pretty cool. And even though it's Django, it's not just Python. There's a whole bunch of languages underneath. There's a whole bunch of languages involved. So it's kind of, I don't know, for me it was kind of interesting when it first open sourced June 1st to try and bring it up on my Mac. It was kind of fun. So there's 28 universities involved worldwide. Google had built Course Builder. You can look at it. I've got some links that'll be on the slides I'll post. But just Tuesday they announced they're going to continue to serve the courses that are on Course Builder, but they're stopping developing on it. They're joining development for edX, which is, I think, really good news. And Stanford had Class to Go, which is also a Django solution. And it's got some pretty interesting things. So the repository is still there, and that's good to look at. There's another one, Coursera, that also looks like it's Django and Node mix, similar, but it's closed source. It's sort of competition. And from my earlier piece of the talk, I predict, based on history, that they're going to die a terrible and gruesome death because they're closed. Because that's, I think, the nature of how things go. And I'll talk more about that in my last talk tonight. So here's the other open source things, at least. Class to Go, which is closed, but you can still look at it. And the Stanford repo on GitHub is still useful because they have theming and they have all sorts of things that aren't in the main source tree yet. And they have a really simple way of writing questions and tests in a modified version of Markdown, which is called QuizDowns. That's kind of an interesting piece of code to go through. And then there's Khan and Khan Lite, which I don't know if you've ever seen any of the courses or gone through any of them at the Khan Academy, but I think their main target is third world countries where there's no internet and you want a really light thing you can carry in on your laptop and deliver things without a lot of resources to classes. So that's there. And then there's a Ruby solution, which is open source, that's called Canvas LMS. So that's about it in the open source current MOOC sphere. The commercial ones are, well, at least there's a couple of them. There's even more. Actually, if you Google for a list of MOOC courses, you'll find a couple of dozen competitors trying to hang on, just like none of the Plato spin-offs were able to 20 years ago. So 50 years of lesson is lost. That's why I kind of wanted to present that at the start. So, so let's take a look at what this edX thing looks like a little bit. So I tried to write this all out, and it gets kind of messy, but general organization that you all probably are familiar with, we're talking web app. So there's model view controller, and then there's services or utilities or things out there. So basically edX is two servers. One for content management system, which is what developers of courses use. And you can write things to process answers in Python there, or you can use canned stuff. And then there's the delivery system, which is what they call the learning management system. So It's pretty simple. That Django server talks to students, and it gets course content out of either a Mongo database or XML, and it calls on servers to run in the background, especially for quizzes and things that don't need immediate grading, like submitting programs for a quiz, to external graders, to video services, to YouTube and so forth, and other services. The source tree basically has a bunch of stuff, but the interesting things are 3 subdirectories. They're LMS, CMS, and then a common area that does authorization, XBlock, which I'm not sure if they're quite rolled out. They're working on XBlock, but XBlock and XModule are the same thing. It's a way to have a live plugin module into your Django app, basically. And then Kappa, if you aren't into education, you can look at lon-kappa.org, that's LON, and that's a way to randomize questions. So if you have, let's say, physics tests, and you have 50 questions, but you present 20 of them for a quiz, everybody will get a different question. It'll randomize the values in the questions and so forth. So because edX is trying to be portable amongst other education delivery systems, on Kappa is a big thing. So here's what the source tree directory looks like, and I've highlighted the 3 things that are sort of on the architectural map. There's CMS, there's Common, and there's LMS. There's a bunch of other things you might notice that aren't strange, but some of them might be. There's node modules, and there's a rake library. So, we've got Ruby running here too. This, Ike Chang from MIT sent me this. This is what he had from the fall of last year. I tried drawing this out on my map, and it was so messy it hurt my eyes to see, so I decided not to show you. But there's sort of what the running system looks like. Authenticators with different backends, all sorts of storage backends, because there's SQL and Mongo both working on basically 2 separate Django servers that are cooperating and sharing resources, which is kind of interesting. So the code's big enough that this is one of the bug fixes from the edX platform, where there's internal people asking for other people to review, because most people aren't familiar with the whole code base. I sure as heck aren't. I contribute, and I've done some things for deployment and bring up and so forth. So here's kind of what's involved in the edX software stack. There's CoffeeScript is in there too. It's not on here, but it's in there too. But basically it's run by Nginx and jQuery and Mako templates in place of Django templates, and MySQL and Mongo both. The division of the stuff that's the Django apps in all of these various servers are courseware, instructor, and common clients. And I won't go through all of these because I'm burning time. And the components to deliver external services. So YouTube component and custom event players and so forth.
What's a Kappa problem?
Lon Kappa is the randomization system. So Kappa is a problem that you present to student randomized. You design it according to, if you look at lon-kappa.org, they've got examples and demos, but basically it's an educational standard for I don't know how long. I'm not an educator, so I couldn't tell you much about it, except that I know it exists and I've read up enough about it. Okay, so doing development with all of this means you're not going to be using virtual environment. Everything's done through VMs. So you also have different VMs for different functions. So what is it that you need to develop? Well, there's a kick the tires phase where you want to just get something up to see what this is all about. There's enough there. And for that, you want a pre-configured instance. And there is a pre-configured instance. To develop on the platform, you want the source tree. and you want to be able to look at code with your browser like I do on my Mac, but it's running the system's running in a virtual machine on Ubuntu 12.04 LTS, but the local host machine's network mounted, basically the Git tree. So every time I make a change, I can still look at my browser and log into the VM and do whatever I need. So that's what you want for developing on the platform. And then for authoring, you either want a sandbox for learning, or the development tree if you're developing processors or plugins for teachers, or a deployed studio instance, even if it's on your laptop in a VM, if you're going to give it to a professor or somebody, even from Chippy, who wants to maybe develop a Python course. So you want the real thing so you can get as close to what's going to be out in the cloud. And deployment is a big task in this source tree. So not only for skinning and figuring out where you're going to deploy, Harvard and MIT deploys to Amazon. I'm guessing, I'm betting that Google's getting on board. Part of their announcement with the edX team was they want to make edX easily accessible to people who don't have the resource to maintain and host their own systems. So I'm kind of expecting custom edX apps that you can just bring up on app server on GAE. So my expectation is there's going to be, so deployment's an issue. There's AWS, there's app server, there's getting things on your local networks, and at least at University of Chicago, there's a big research cloud, which is OpenStack based, Open Science Data Cloud, where there's researchers that do medical stuff there that want to have instructional material, but it can't be in the open space. So that's kind of what I'm working on and why I'm interested in this. So deployment's an issue. It's a job. It's a whole development task on itself. So what are the current options? The current options is there's a sandbox that edX runs. So you can just go off onto it and play around with it. It may not be current, but that's easy. Then Ike Chang from MIT has a completely deployed VM instance, which means you're not going to have the newest code. It's the newest code as the last time you made the instance, but it's got lots of nice tools for playing around. So that's probably, for me, for most people I talk to, that's what I recommend as the first step, because you can get in there and play with it and do real work. And for development, I worked with a couple of other people that weren't part of edX to get a vagrant bring up on the source tree. And the work's actually really nice. And it's pretty fast and it's pretty dead simple. It's kind of as simple as this. You clone the repository. It includes the vagrant file for startup, and there's a shell script that will build the VM for you the first time. So basically this is all you do. Well, not really. You have to install Vagrant 2 and you have to have a VirtualBox downloaded, but it's pretty much this simple. And then for deployment, this is probably the roughest out of all of these. Right now on GitHub, there's a repository called configuration, which is where the edX team is trying to automate everything for AWS bring up. And there's a Vagrant bring up there, but there's none of the niceties or tools that Ike has from MIT. And at least me and one other person are looking at porting some of Ike's tools to make this as easy so people can deploy on local servers or whatever. So now I'm into the last 10 minutes. And shall we bring something up? Do you guys want to see it? Or should I just keep walking through it?
Yeah.
All right. So this is, boy, this doesn't show really good. Okay, let me move this over. So this is a directory with basically nothing more than Ike's VM, which came down as one of these boxes. So he built his last one September 13th. And this is all the more we do. Let's see what the status is. Does anybody know, has anybody used Vagrant around here? Yeah, okay, good.
The ring tree does.
So we had, I'm on the talk review committee for PyCon, and somebody submitted a talk on learning Ruby for Python programmers, and the review committee had interesting reactions to it. And I'm the volunteer coordinator, so I like helping people. And my one single strong comment was, we're the welcoming community, the Python community, and with edX you welcome everybody else's language, because even the graders, there's Ruby graders calling on the Django app, so playing nice is the whole game. So I kind of like the concept here. So we've got it off. I should have brought it up while I was talking, because it's dead and off. And I see I can bring this out of there. It's still spinning, so it's still coming up. So I should be up. I kind of don't remember what the login is here, so if I look at Ike's instructions here and building this, there we go, vagrant SSH manage help. So he's built a manage tool. Let me try that. There it is, xadmin at MIT xvm local with xadmin. Good, thanks, Ike. So let's see, xadmin at MIT xvm local xadmin. Yes, well, you know what they say about demos. MIT xvm xadmin. Is it spinning on me?
No, you're not. Wrong domain, good sir. Check the URL.
Ah! Right, I'm on the, yeah, right, thank you. Well, that'll do it every time. And there we are. So one of the things that I want to point out, we can look at this. There's the test course he put in and included this. Doesn't have very much in it. So we can go through how you order and add things. But the more interesting thing for starters is if you look for help, you can actually download the PDF documentation. And if you, that's actually a hard link out to edX.org. So that's the whole how do you write courses. And you can do the same thing with too much VM? Thank you. With enrolling in edX 101 out at edge.edx.org. So that's a class on how to write classes. Let's see, what else do I want to show you here? So I think I'm going to stop this VM because one of the things I want to show you is how you build documentation off of the current thing. And you do that with Rake. And we can certainly, I think, do that here. Nope, this one's not set up. Let's see, edX, all. Nope. Well, the thing is this is a deployed version, so it doesn't have the virtual environment, and basically Rake runs with the Django manage program, which isn't running on this because we're running Nginx. So that's kind of. Okay, so this is the Git checked out current repository. So the difference here is this is all running on virtual machine, and by default it takes you to opt area, which is actually all network mounted from the host. So here, if I say this, I get everything. This should do it. And that is how we get to this is probably the easier way to do this. Let's do this. So here's the live, most current. How do you get started with building an account? I mean, building a course. And probably the most, let's see, custom responses are things that you write Python scripts to. So you can do your own graders without writing a plugin. You can just do it as part of your course. Okay, so let me get back to my see if I even did what I said. Yeah? I didn't bring this up, but you can bring it up. Oh, I could have also logged into the development machine, which is still running. I could do it if you want. Bringing it up as a local host instance and port forwarding back to the host. So in that way, you don't have to really change anything. You can get all the Django debug toolbar. And you get to do tracebacks if you're doing debugging. So you don't really need to play with configuration. You just change the way that, that you run the server. So, did I say 40 minutes? Yeah, I was kind of going there. So here's where all the information is. Code.edx.org will show you most of everything. Engineering.edx.org is posts with information. You want to look at the wiki. The files, getting started with Studio is what's the link at the bottom when I logged into that Studio instance of Ike's from MIT. And it'll show up also on your development version. It doesn't matter which version you go to. MOOC.org is the new announcement that, actually that's a pretty good one. No, I'm not going to do that. MOOC.org is the announcement that Google made with edX on how they intend to make hosting be available for anybody who wants to do this. There's key repos. We're going to kick me off the stage any minute. There's one thing I want to point out of example sites. So besides edX.org, there's Stanford that mixes a bunch of different deliveries. But the really interesting one is education.mongodb.com. So it's not just for universities. They've got how to use Mongo, how to deploy Mongo.
I'm not making that flash.
Okay. And I think some good project ideas, if anybody want to have a project night on this, is just getting up and authoring a course. We could do a Python introductory if we wanted to. XBlock, since it's new. And there's a gap in the courseware tools. So edX is trying to do large grade your essays thing, or you can do string matching where the string has to be, except for ignoring case, has to be an exact match. So if there's a typo or anything, it can't handle it. Well, heck, Plato handled that back in the 60s, including things that are more complex without getting into natural language processing. So that would be a really good thing to give back to edX. And then a deployment workshop might be good. Actually, I want to get something up for OpenStack. Also, there's another piece, the VPython. Bruce Sherwood has a language compiled version of CoffeeScript of that running in the browser. And it's glowscript.org if you want to go in there, where you see three-dimensional models, live, interactive, very responsive. That would be a nice thing to add into the edX thing. And that's it.
All right, so we got questions?
Yeah.
Man, might need to give you the mic. Oh, by the way, your pre-curriculum should be at the next presentation that we want to have.
Well, you mentioned at the beginning of your talk that there were some criticisms of Django. Given these criticisms, can you talk about why you chose Django? Because of, given these criticisms?
Well, first of all, I'm not part of the edX team. I just happened to notice a couple of people I know, they got jobs there before it was all open sourced. So I heard that it was open sourcing before it was announced, so I got all excited. I did used to work on Plato in the 70s. I was a manager of a lab at University of Arizona. But I'll answer this way. Most of the performance issues, and this is, I think, what most Django people will tell you, are not about the server serving things to clients. The network's slower than anything the server can do. And where there's graders that get complex, for example, there's a friend of mine at Berkely that teaches a course on software as a service. It's all a Ruby course. He has a Ruby grader. He jumped to edX from Coursera because the API and the interface of running his own software as services were much better. So the interoperability is good, and if you need something with speed, you provide that service with speed. But if you need to get something up and you can hook things in, Django works well. I think for me the weirdest thing was when you go into the development version and you see what's available from manage.py, and there's only two things available, and that is either start up the LMS or the CMS version. So it tiers and it layers nicely, and performance just isn't an issue.
Any more questions?
I saw Plato back in the 80s, and from what I recall, I saw Plato back in the 80s, and it was pretty amazing, and I seem to remember it did like interactive physics demos and things. Is there like frontage to do that type of stuff?
That's one of the projects I suggested, and I don't know if they'll let me do this, but let's see, what was it? glowscript.org. So one of the things that that is a relic, basically, of sort of like a couple of cascades later from. This is all running in the browser, and it's all written in a high-level language that looks a lot like, not like JavaScript, not even like CoffeeScript. It's higher version than that, but it's all compiled in the browser, and this is also open source. So this is kind of, let's see, there's another sort of interesting demo, if I can, there it is, Stonehenge run with CoffeeScript. So this, let's see if I can do this. Move the mouse up to the edge of the center and move it.
So is that HTML5?
Yeah, this is all HTML5. It depends on that. But basically, this is all running real time in your browser. And the whole scene's described in, let's see, edit this program. This is what's running there. So what would be interesting, what an interesting project would be, is to get this integrated with the template so you can actually, so an instructor could actually incorporate it as part of a course.
So there's no authoring language for that?
Not, well, there is, but not this in particular. And I think that's that would be an interesting Friday night project, I think. I think it would take a couple of Saturdays maybe to get this all integrated in. So, yeah.
One more question? One more? Last question.
You mentioned that you're going to be able to move for Python, but there are several MOOCs already for Python. I'm sorry, keep up. There are several MOOCs already for Python. Why not move on to Django?
The question is, why not move on to Django? Because there's already multiple MOOCs for Python?
Yeah.
Yeah, I know of one, or at least I know in detail of one course that's on Coursera, which is the closed source system, where I dug into it. The Python you run is compiled to JavaScript and runs completely in the browser so that students can be disconnected, but it's not open source. The course isn't open source.
Right, that's Code Sculptor.
Yeah, that's Code Sculptor, right. That's exactly right. I don't know if there's any Django tutorials.
No, I haven't found it. University of Toronto also has a MOOC.
University of Toronto also
Has actually 2 MOOCs for Python. Dr. Chuck, who runs Sakai. I'm sorry.
It's a 4-part question.
But by the way, here's
Dr. Chuck, who runs Sakai, also has his own MOOC.
right, and here's just to show. Here's a customized MOOC powered by edX that's just MongoDB, and this is really for clients. Notice the nice snake on this one here, the nice snake image. So, see, here it's for Node and for Java, but developers, you don't need to define the language, because we all know real developers program in Python, right?
All right. Thank you very much.
Okay.
Good job, man.